Welcome. Today's video, we're doing a quick rundown of the coordinate plane. So we're not going to get too far into a lot of different things, but we'll touch on some things that we'll see in dealing with the coordinate plane. But I want to make sure that we have the basics down before you start jumping into some of these complex functions and different things like that. So let's do a quick review of our coordinate plane. So a coordinate plane, again, it's like a number line, but a number line just moves right and left. It's just horizontal. We have the origin and then positive 1, 2, 3. We've worked with number lines since probably elementary school. But now we're adding in a second axis that's going vertical as well, up and down. So this is our coordinate plane. It's now two-dimensional. Instead of just moving one-dimensionally along a number line, we're going to be moving right and left and up and down. So we have some different things that we need to label and understand. First, this horizontal axis is the x-axis, and then this vertical axis is the y-axis. And again, it's always that way. We don't flip them. If we're saying plural, we don't say axes, we say axes. I know it sounds kind of weird, but we're looking at our two axes right now. Down the road, they'll add in a third dimension, z. You can plot things three-dimensionally, but we definitely will not be doing that in any of our classes, just two-dimensional. So x and y axes. Okay, then, well, how do we plot things on this? Well, we're always giving either a function, or if we're just plotting a point, we're given an ordered pair. Okay, so we'll be given a number. The x value is always given first. We can't just pick and choose. It's always the x and then the y. Okay, x and y. So if we're given something like 3, 2, well, our x is a positive 3, so I'm going to go over 1, 2, 3. And then the y value is a positive 2, so I'm going to go up 1, 2, and plot my point. Okay, now let's say we have something like negative 3, 0. Okay, so I'm going to the left 3 because that's my x value. Again, the first number tells us whether we move right or left. Positive number, we move right of the origin. Negative number, we move to the left. So negative 1, 2, 3, and then I'm up 0, so that's actually going to be right there. Let's say we have something like this. Positive 1, negative 4. Again, my ordered pair. Go over 1, positive 1, and then down 1, 2, 3, 4. Okay, and there's my point. So plotting points over and up. Okay, to the left, and in this case, we didn't go up. So positive. So all values in this quadrant, and this is our first quadrant, and then we move counterclockwise. So this is actually our second quadrant, and in this, the x values are negative because we're to the left of the origin, but we're still above the origin, so our y values are still positive. Okay, we go to our third quadrant. In this, we're still left of the origin, and we're down, so in both of our values of our ordered pair are going to be negative in the third quadrant. And then our fourth quadrant, x is positive, but we're still below the origin, so the y is negative. So we're looking at those. Now, what are we going to see besides just plotting points? Well, we can plot shapes. Okay, well, we've probably seen some problems already this year where you have to plot like the 4 axes of a rectangle, or three vertices of a triangle, or something like that. So we can plot the points, we can do dilations, we can do functions in here. So again, a quick review of a function. Say we have something like a line right here. This would be a linear function because it's a line. It continues on infinitely in both directions, and it passes the vertical line test. So if we draw a vertical line anywhere on this function, it only crosses one point, so it's a function. We could go back to, we'll work a little bit with parabolas this year. So this is a parabola, kind of that U, or it can be look like a frowny face and be opening downward. This is also a function, because if we were to just draw a bunch of straight lines up and down, it would only pass through one point. If we draw something like this would not be a function, because if we draw a straight line here, it crosses 1, 2 points. So this input, my x is always my input, y is always my output, or x is my independent variable and y is my dependent variable, because we need to know x in order to know y on our functions. So I put in one input and I get two outputs. That tells me that's not a function. Or easier than remembering input, output, all of that is draw a straight line that can only cross the function at one point everywhere. It's a function. If it crosses more than one point, it is not a function. So this one is not a function. Another common function that we work with is direct variation, and those will focus primarily on the first quadrant, because we're using real examples like side length of a square compared to the perimeter, or total weekly paycheck compared to hours worked. How many hours we work determines how much money we make, or something like that. So usually we're working in the first quadrant because all of our real world values are positive numbers. So in order for something to be direct variation, it needs to go through the origin, and it needs to be linear. So this is linear and goes to the origin. Something like this goes to the origin but is not linear. It's not directly proportional. And something like this that's linear but doesn't go through the origin, it's not directly proportional. And that equation is y equals kx. K is our constant of proportionality. So again, if I make $8 an hour, I work 1 hour, I make $8. I work 2 hours, I make $16. I work 3 hours, I make $24. So directly proportional. Something where, let's say, a taxi cab, it's $1 per mile or something like that, but you pay $2 up front, regardless of if you go 1 mile or 100 miles, that's going to be up here. It's not going through the origin, because even if I travel 0 miles, I got in the cab, I still have to pay that $2, for example. And then I'm going to get too heavy into functions, because this was just kind of a review of the coordinate plane, but we will also see inverse variation functions, and that's y equals our constant divided by x. So as this gets bigger, we're dividing this constant by a bigger and bigger and bigger number. This is going to get smaller. So as we see x continuing to go out, y is going to get smaller, but it's not linear, because it's being divided by a larger and larger number. So it's going to keep getting infinitely smaller. And these are actually never going to cross the x-axis or the y-axis, because I can't put in 0 for x, because I can't divide anything by 0. It's undefined. So, and we'll show you a little bit more with that down the road. But just some review of the coordinate plane: first quadrant, second, third, fourth. We can plot functions, we can draw shapes, we can do slides, translations, dilations, different things with those shapes in a coordinate plane. But the basics is remembering the x-axis, the y-axis, ordered pairs, and how to plot those ordered pairs.